Okay.
Okay, so let me share my screen. I believe we're able to see the slides.
Yes, we
Oh,
can.
perfect. So this is especially for those who, like, I'll just give you the brief introduction for those who had not um, attended the previous overview. So just to give you a theme of what this competition is about. So outline will have something about lighter than air systems, importance of emergency rapid deflation device, then what is the problem statement, materials, fabrication, and resources. So lighter than air systems, as the name suggests, the whole system, if it is buoyant or the average weight or the density of the system is less than the air, then the system is going to stay in the air by itself, like without use of any extra energy. So this is more like you must have seen kids playing with helium balloons, or you must have seen hot air balloons for some fun activity. So this has been around for a while, and but in 1930s, after a few disasters, we saw fewer lighter than air systems. Then it came back in 1980s because they can be identified as environment friendly because you do not need to expend a lot of power to stay afloat. And it's slowly coming out as one of the major disciplines. There are a few benefits. Okay, let me just put highlight a pen. Okay, so there are a few benefits and some concerns about lighter than air systems. So one thing is it's very efficient because you do not need any extra energy for staying there. But on the other side, it's slower and susceptible to weather changes. On the other side, heavier than air systems like your fixed wing aircraft, helicopters, and such, they rely on aerodynamic lift for staying for flying and need much more power or energy to do so. But they are faster and less susceptible to weather changes. So the conventional LTS systems include airships, aerostats, and hot air balloons. Our current concern is going to be on aerostats itself. Um, and so as the aerostat, what it means is it's something that stays static or it's actually tethered to the ground, has some payload which may be communications, surveillance. It's not expected to go from one point to the other. It is only expected to um, hover like a helicopter, but just stay at a place. So ideally, we would like to have higher payload capacity. Um, we would like it to be at a given altitude. And even if there are some wind gust conditions, we want this aerostat to stay stable. So this is one such aerostat system. Here on a truck and using a winch, this aerostat has been hoisted. Here are some specifications for the same. So now what is ERDD? So ERDD is emergency rapid deflation device. Now, in case, let's say in this previous example, if this tether breaks, then this aerostat will just go up in the air and you cannot control it. You cannot retrieve it back. So it is now required by the law and for safety actually that it needs to have some some emergency rapid deflation device or a safety device which brings down the aerostat in a controlled manner. Because if you do not do so, then the aerostat may actually go up and can go to the altitude where you have other air traffic, like fixed wing traffic or helicopter traffic. So it could be a very risky operation. So this is the motive why ERAD is there, and hence the competition. In the competition, also we are tasked with designing and testing this ERDD system. So here we have a video of destructive ERDD. So just this is a 5-minute video.
Ronil, may I suggest something? This video is available on our YouTube channel. They can watch
Yes.
it later because right now audio is not coming clearly. You can just go ahead.
Okay. So if somebody is interested, please go through the YouTube channel and you'll find the video there. So problem statement. Uh, the ERDD that you develop should not damage the envelope. So yes, you need to come down, but that should be controlled and with so in a way that you can still reuse the envelope. You'd not also want to damage the payload. Sometimes the payload could be of very high value. So if you fall like a brick, then you will definitely damage the payload. So we need controlled descent rate, and the impact on the payload should be low. We have you need two modes of operation. One is autonomous detection of tether breakage, which means if the tether breaks, this system should come and immediately work towards getting the envelope uh, down. The other one is remote command. It means you want to get the thing, get the aerostat back to the ground soon, but this is even before or even if this is not due to the tether breakage. You just need the aerostat to come down soon. So here are some constraints that you need to follow when you design and make your systems. The all-up weight, which means envelope and ERDD and everything that we would be putting on a weighing scale, it should not exceed 1.3 kgs. The pillow envelope or amount of the volume of gas that we put into your aerostat, it will be less than 1.5 meter cube. So you have to design your aerostat or the shape whatever you take to hold less than or equal to 1.5 meter cube. Now, when this aerostat or when this pillow is hoisted using the tether, the minimum tension this tether needs to have is 0.2 kilogram force. If it is less than that, it just means that your aerostat is not creating sufficient lift to meet the requirement. The maximum allowable altitude, this is regarding like once you cut the tether, once we cut the tether, this ERDD system has to act in a way that the aerostat does not ascend more than 16 meters, because after that it will touch the ceiling of the corridor. And your design has to be such that it is not leaking. So once we fill it on the competition day, or on the first day of the competition, we want it to stay that way without leakage throughout the night. Um, this is kind of important because if you design a safety system which is itself is a leaky system, then you would end up wasting a lot of helium, and helium is a very expensive resource. So operationally speaking, you leak like one has to create designs that are leak proof. So there are a few materials that can be used for envelopes. Um, Low density polyethylene, metallized polyethylene, uh, and PVC plastics. There are a few fabrication methods. You can refer to these, and depending on what is available to you, you can choose to use any of these materials and the fabrication methods. So here is a sample image of a pillow envelope. This is one of the simplest things you can create to hold the gas. Here are some timelines. These are already posted on the website. And there are a few other resources. You have a YouTube channel, you have online course, and NPTEL course as well. And we are going to have webinars like this. There was one before, and this is the second one. So this is, thanks for attention. If you have any questions, you can raise your hand and Okay. Any questions?
Hello, sir. My name is
Yeah.
Sankara,
Mhm.
and I need to ask that what will be the surface area of the envelope?
What will be surface area of the envelope? So, if you have 1.5 meter cube as the maximum volume, and depending on what shape you choose, then you will come across, you can calculate how much will be your surface area, right? Now, so this, like if you're choosing something like a pillow shape, then the surface area, um, you can calculate using some expressions. So, just a second. We have some help here. Okay. So from what we have tried, 3.2 meters width and 4 meters length would give you approximately the like this size of the pillow. This size of the pillow would give you approximately the required volume of 1.5 liters, 1.5 meter cube. Yes, that deflection must happen using tether or our device should be attached only to the aerostat. Okay, so okay, let me just read questions from beginning. We have uh, Kesia, right? Yeah. We were told of payload last time. What would be the weight? I think the weight would be less than 5 to 10 grams. Can somebody just confirm?
No, it will be even lower than that. The payload might be only about 2 grams, 2.5 grams.
Right.
It's a very lightweight payload. But you can budget for 5 grams for payload.
Then the deflation must happen using tether or our device should be attached wholly to the aerostat. The device should be attached wholly to the aerostat because if the device is connected to the tether, you like it has to have some contact with the aerostat. Otherwise, I don't know how you intend to um, remove the gas.
Yeah, it
Or
may.
if your question is if some sensor is attached to the tether, then you would need something for measuring the tension. Once the tension is lost, then you are deploying the ERDD. Is that your question?
That's
I'm
right.
not sure whether I understand.
Yeah. Let me just clarify. So we want the deflation device to be mounted on the aerostat because that is how you will deflate. But you may have an additional sensor on the tether because you have to sense the persistent loss of tension. You can use some other means also. Gaurav Mehta has
Then
a question regarding, take over.
yes. So do we need to add calculations also in the design report, like airflow discharge rate and time of descent? Well, yes. To say whether your design works or not, you need to defend your calculations, your sizing methods. So some basic calculations, some back of the envelope calculations you also do as long as you can support them in engineering way. Don't make it too vague though. Okay, then
So
we
if
have
I
one
can
more question.
add,
Please.
Gaurav and other people who are listening, see, the purpose of the design report is to get confidence that you know what to do and you have a reasonable sense. Okay, so whatever you give in the report that gives us confidence that you have done the work carefully will help us to decide whether to shortlist you or not. So on one hand, we are not insisting on detailed calculations. Okay, now There are some questions on the chat. Dhwanil, will you like to take that? From Mayank, there is a question.
Yes. So, okay, this is a long one. Okay. Where will the plug for inflation be located? Well, that actually depends on how you design it on your aerostat. Then, are we allowed to puncture the aerostat for deflation purpose? That is no, because we need the aerostat envelope to stay intact and reusable immediately. What will be the reference height for the aerostat when attached to the tether? That is 2 meters. So that so after it is like once it is tethered, before breakage of the tether, the aerostat will be about 2 meters high from the ground. Then we have questions from Asta. After submitting the abstract, if you find error in the design and made alterations to the design, will that be accepted later? So if you make all small adjustments, let's say in size or some of these, like some parameters, it's okay. But if you completely change your design, that will be not be fully accepted. So, but Professor Pant, if you want to comment on that aspect.
Yeah,
you're muted,
I'd like to say, see, you cannot change your design. Dhanil, you may stop sharing the PPT.
Sure.
Look, we cannot allow people to completely wholesale change the design, but we know that when you experiment, when you practice, certain changes are made, which is acceptable. But if you say that we will submit some report just to put our foot on the door, put in the door, and then tomorrow we will give the design, that will not be acceptable. All right. There is a question about the pressure of helium inside the envelope. Well, the pressure is going to be slightly more than atmospheric because just to maintain the shape.
Then
Aryan
we have
has a
one
question.
more.
Yeah,
Yes.
about size of the. So, Dhoni, you can take some questions, and if there is a problem, I will kick in.
Sure. There is one participant who has listed down quite a few doubts. So let me just read them. What will be the reference height of LTA aircraft from where it will start to lose pressure? That is, aircraft will be released from the ground zero, or will it be deflated, depressurized, and midair at particular reference height? Okay, so your system, your ERDD can jump into action almost immediately, like it's totally up to your design. You do not have to wait until the aerostat reaches a certain height to start deflating. Okay, so if your system is quick response, that's a plus for you. What would be the buoyant force acting on the balloons? Well, I think you can answer that. The whole system weighs something, and ultimately your tether tension is less than 0.2 kg force. So basically 200 gram force is the total net buoyant force acting on the balloon, right? Surface area of the balloon, I discussed that. It depends on the shape you choose, but you can do the calculations. So we said like 3.2 by 4 meters times 2. So that much, approximately that much material you are looking at for making a pillow that can support 1.5 liters. But you need to do your calculations. These are just some rough numbers. Mass and dimension of the object, payload. So mass, we discussed, it could be 2 to 3 grams, but you can account for up to 5 grams. Dimension could be 1 to 2 inches. And some of these things have been mentioned in the FAQ too. So please go through the FAQ document for some of these stuffs. Details about maximum ceiling height and other parameters. So maximum ceiling height is about, okay, so, right. So the maximum ceiling height is about 20 meters and the tether length is going to be 2 meters. So you have 20 minus 2 plus whatever aerostat dimension you have in that direction. So that much distance you have to get your aerostat under control and start descending. Okay, so pressure of the helium, I think Professor Pant addressed this question. Um, can we increase the size of aerostat balloon to increase weight to lift ratio? Okay, so there's constraint on the maximum amount of helium you can fill, or the volume that you have to put in your aerostat has to be less than 1.5 meter cube. So if you exceed that, then you will be disqualified because that's a hard requirement. Does ERDD need to be complete electronics, or can we include mechanical systems? Yes, you are free to use any system, electrical, mechanical, electromechanical, as long as you satisfy the constraints, you and meet the requirements, that you are free to use any system. Can we use hydrogen for the lab test? Now here there is a problem. Like, see, first of all, hydrogen will have more buoyancy. That's one. So if you have done some calculations, they won't be very accurate. The other problem is that if you're using hydrogen, maybe your location wherever you are, if you do not take proper care, you this is a potential hazard. So if hydrogen leaks and you are not careful and there's a spark, you will be like. So we basically do not want you to try anything with hydrogen wherever you are. It has to be only be done under some really good supervision, somebody who has been handling hydrogen for a long time. Okay, can we submit more than one ideas because we don't know which will perform better or which will fail to achieve the required parameters boundations? Yes, I think you can submit more than one ideas, but just be sure that your each idea is supported enough. Like you have some page constraint, you have and you want to put both the ideas, but make please mention them clearly enough so that we understand what you are discussing. Okay. Next is the question is that the envelope which will be provided to us via ERDD will be of which shape? So this will be, I think, pillow-shaped ERDD, pillow-shaped envelope. That is the basic shape, and that's like easiest to build and easier for you to deal with for sticking or implanting your ERDD device. In the report submission, do we have to add some sort of animation of entire process, or is the design submission sufficient? Well, design submission is sufficient. You do not need to provide an animation. If you have, it's okay. You can provide a link to it. But just CAD drawings or proper, decently labeled hand drawings are also okay. You should be able to express your designs properly. Okay, Ashish Kumar says, does ERDD have? Okay, I think I covered this question. Did I miss any question? Like, if I did, please. Okay. Now, Tejaswini asks, what should be the impact velocity when aerostat is near to hit the ground? Can you give us an idea about what will be the payload material? I think Professor Pant, do you want to comment on this?
So payload is a secret. We don't want to talk about it much. Okay, because we want it to be a surprise for you. So I will just tell you that it will be something like almost like a spherical object, very fragile, roughly 1.5 to 2 inches in dia and maximum 3 to 5 grams. That's all. It will be stuck by sellotape to the bottom of the envelope. And we don't want it to break when your aerostat hits the ground. This is to prevent excessive leakage of gas from the envelope, which will cause damage to the payload.
Right. So I think impact velocity, you can try to guess or maybe try to make it very gentle. But
There's
this
no
is all the
number
clue
for it.
that you.
There is no number for it.
There's no number for it. This is all the clue that you will get. Okay, so window envelope provided by you guys will have the place to attach the tether, or we need to decide the place, the mounting for the tether.
Let me
You will have to
clarify.
decide.
Let me clarify,
Yes.
Devyanshu. We are not going to give you an envelope, because if we give you the envelope, then you will have to cut it anyway to install your device. So what we are going to give you, we are going to give you 2 sheets. And when you join all the 4 edges, you get the pillow. This will be easy for you. Okay. Earlier we said that we'll give a pillow, but then our team members told us that if you give a pillow, then how will the people cut the top portion and insert the device? So it's easier for us to send you 2 sheets of fabric. You install your device on 1 sheet, that is the top sheet, do all the work, and then just seal all the 4 edges using a small iron, which we will demonstrate to you in one of the webinars. The second thing is, tether attachment is your job. You will decide. We will not give you the tether, or we will not give you the tether attachment.
Okay, so I think we get through all the questions. Yeah. So anything else that you guys want to ask? No further questions.
So all
So
the teams
report
may know
submission that
we are here to help you out. So you can ask your questions right now. And no question is silly or bad, please.
is the design 2D is sufficient, or we have to add in 3D? Design in 2D means your ERDD device. If you just want to provide drawings, well, that is okay, but please make your drawings really good so that we can understand how the thing looks like in 3D. Okay, do we have to submit the report via email? We will be sharing a Google form soon, through which you can submit your report. The reports will have to be in PDF format. There will be some size constraint for 5 MB or 10 MB, something like that. And I think the format of the report has also been shared on the website. Okay, can you please extend the deadline for report submission by a few more days? Okay, Professor Pant, do you want to comment on this?
No, Tejaswini, we need to have a genuine reason for that. So if you want to an extension in the deadline, you have to send a mail to that address mentioned, explaining the reason. And if we find it to be worthwhile, then we might take a call, but we cannot give a blanket extension. I don't think it is fair on all the teams.
Okay.
Okay, any other?
Okay.
Well,
So if we do not,
yeah, sorry. Go ahead. You go ahead.
I think like if you don't get questions in 2-3 more minutes, then I guess it's it.
Okay, there is one question to me, a direct message, which says that this student has some doubts regarding the idea. Can I personally ask you doubts after the session? I'm sorry. We don't want to encourage this kind of lateral discussion. Whatever doubts you have to ask only on the email address, and then our team will get back to you. We will not like to talk to individual teams or individual students to discuss their ideas. Whatever ideas you have, whatever doubts you have, there is an email address, erdd@aero.iitb.ac.in, right? So just send a mail to that. It ultimately comes to me only, but our whole team discusses it.
Question is, how often are aerostats brought back to ground? Now, Aryan, is this question regarding, in the competition or in general? In general. So, Professor, do you want to answer?
Yes. So commercially available aerostats, normally they say that it can be deployed for 1 month non-stop at any particular location without the need to bring it down. You bring it down only for doing any maintenance or changing the payload. Okay, but that is for the commercial aerostats, which use a very good quality material, very expensive material. I would say a typical aerostat with the reasonably good material can stay afloat for about 2 weeks. So the ones that we make with the standard materials with some coating, we have seen that the endurance of 2 weeks is not a problem. So it varies from approximately 2 weeks to 4 weeks. After 4 weeks, we bring it down for basically cleaning up the surface, because there can be bird droppings, there can be accumulation of dust, which can cause a problem.
And I think when it is brought down, it's not necessarily by deflating it, correct?
No. Very expensive. That's a very
Right.
expensive
So
proposition. We don't deflate.
So you just winch it back. You basically pull the tether back so that the aerostat comes down.
In fact, we can conduct a webinar on general introduction to aerostats later, once we get the reports, because now reports is due only a few days from now. So once we shortlist the teams, we might be able to do a more detailed webinar on typical aerostat, because you are generating interest in aerostats, which is also our purpose. So we will be happy to do a webinar on introduction to aerostats, but not right now. Right now, I would suggest you focus on the, okay.
Okay, so the question is, when will a certificate of participation will be provided?
Well, after the report is received and after the report is evaluated, if we feel that your work is not frivolous, just taking part for the taking part sake, then we will give you a certificate. But if we feel that you have put in serious efforts, then definitely we'll be able to give you. Even if we don't shortlist you, if we are convinced that there was good work, because see, we have to shortlist a limited number of teams. We have logistic issues. We cannot, I would love to have 100 teams, but 100 teams cannot be handled by us. Vignesh has a question about planning to have discrete pockets. Will popping in any of them consider damaging the whole envelope? Well, if you do anything which makes the aerostat unusable, then you are basically damaging the envelope. So if you are popping a small pocket which can be easily patched up, or if you have, let us say, 20 pockets and you just puncture 1 or 2 of them, we might consider that. It depends on the degree of reusability. Our idea is you should not puncture the envelope. Our idea is this competition is more on robotic side. Our idea is you put a valve on the top and you try to open and close the valve remotely rather than puncturing the envelope. Because that is the easiest thing to do and that we have been doing for the last so many years. We just put a nickel wire on the envelope and give current to it. It burns the hole and takes the air gas out. No, we don't want such solutions. We want solutions which makes the aerostat completely reusable without any loss in its payload capacity. So by that account, popping holes in the envelope would render the envelope useless for the next operation. So not permitted.
Okay, Gaurav Mehta is asking how many teams are going to be shortlisted.
So that you
So
please
we-
leave it to us. You don't have to need to know that. That is up to us. Please. That is literally none of your business. It all depends on what kind of sponsorship we get, because we are going to supply you helium, and the money that you are giving us for registration fee is a pittance compared to what we need. The helium that we are going to supply to you is going to be far, far more expensive than what we will take from you.
Okay.
Okay, we will
Any
wait for
other
a couple of minutes more.
Does Ashish is asking, do we have to be more specific about the design in report? But when we say more specific, well, you have to be specific enough to communicate what the design is. Now, the initial report may or may not include the exact part that you may buy from Amazon or Robo or something that you will actually end up using, but at least need to be, what kind of actuators, what kind of sensors, what will the typical size range of those. So those things would need to be there. But when you say specific, like it depends on what level of specificity you are talking about. You don't have to say this specific screw, but you can say this will be fastened by a screw. I guess you get the idea. So are we supposed to keep our payload related to the working of ERDD at the top of the envelope, or can we keep it anywhere? Well, the payload will be stuck at the bottom of the envelope, not at the top. Otherwise, it will never be in harm's way, right? So yes, the payload will be at the bottom, maybe the place where it will contact the ground first. So what is the average power usage of the equipment on the aerostat? Now, average power usage, it depends on what you design, right? Like your actuators, you only know what is your actuator, like how much power demand is for the actuator. So battery sizing, everything is up to you. We cannot say that.
Probably the question is about the larger aerostats. So
Oh,
if it is for larger aerostats, as I said, we will have a separate webinar on that. Can we limit our discussion currently to only the competition, not to aerostats in general? And also, questions should be asked to everyone and not just to individuals. It's not correct to send a message to only me directly or to Professor Dhanush Shukla directly. Better to ask questions to everyone so that everyone comes to know. So Anand, Adarsh Pratap Singh, we have clarified to you, ERDD will be kept on the top of the envelope and payload on the bottom of the envelope. I would recommend that the ERDD is kept on top of the envelope because that will give you the best functionality.
okay. So is it compulsory to use a battery or we can use AC supply? Now you tell me, if you use AC supply and if the tether gets snapped, including the power supply, will your system work or fail? If it will fail, then of course you cannot use the AC supply.
So let
Yeah.
me clarify, in the location of the testing, we cannot assume electrical power to be available to you. Your system should work in the middle of nowhere. So it should be self-sufficient. Another 3 minutes, we will wait. And once again, I repeat, questions should be asked to everyone, not to individuals. I think there are no more questions, Dhwanil. So
Yeah.
thanks to Dhwanil for chairing this webinar. And I think the next webinar will be conducted after the teams are shortlisted. But we will be happy if other teams also, if they want. We will have a webinar as requested. I mean, as we see on general aerostats, that we will open to everybody. But the webinars in the future related to the competition will be open only for the people who are registered. Okay, so there is a message from Adar Prabh Singh that in our device, yes, so that is permitted. That is permitted. You can keep it anywhere. In one of my videos, one of our videos, yes. So you also can do that. Adar Pratap Singh, you can keep your electronics in a box below the envelope. We have no problem. But the puncturing of the release of the gas, not puncturing. The release of the gas, I recommend you do it from the top surface at the maximum thickness portion for maximum results.
Okay, so I think we can conclude the session here. Thank you all for joining. And if you have any further questions, please feel free to write on the email address shared with you. Okay, with that, I think we can end the session, and the recording of the same is available on YouTube.
Yeah. So this particular webinar is being recorded and you will be able to see it on YouTube. We will share the link on the WhatsApp group. Thank you so much. Have a nice evening. And we are really looking forward to some excellent and innovative designs of the ERDD so that